We are going to revise some of the areas using some applications. Let us proceed with some problem. I'm going to show you the problem on screen. Some arrangement of blocks using a spring, and strings are shown. Let's read the question. Three blocks A, B, C are connected with the help of pulleys. String and springs all are ideal as shown in the figure. All the surfaces are smooth. G value is given as 10 meter per second square. Masses of the blocks A, B, C are given, that is 10, 5, 20, root 3, and they are also indicated in the diagram. You're asked to give the tension in the string B and C, and if the string between B and C is cut, then the magnitude of acceleration of block B becomes what? That's the question. Let us proceed. Uh, if you observe in this case, as 20 root 3 is on the left side, 10 on the right side, let us assume, say, the system moves to the left. If at all system move to the left, then as all surfaces are smooth, we can draw the free body diagram for the system. In the free body diagram for this system, 20 root 3 sine 30, 20 root 3 sine 30, which would be 10 root 3, would be acting down the incline. That is mg sine 30. And let's say tension in this string be T1. So, let us say that if this, let us assume, moves with an acceleration A1, and B also should move with an acceleration A1 because they are connected by the same string. And now comes here. If pulley move to the left by X, when will pulley move to the left by X? When block B moves to the left by X, the pulley attached to B also should move to the left by X. There should be increment by X in this string as well as this side. So as the increment is X on both sides, you can see here, the spring elongates by X. And the string has to get that extra length X that would come with block A going up by X. The problem would have been different if instead of spring I would have used a string there also. Then A would have moved up by 2x to provide increment X on both sides of that pulley fixed to 5 kilogram block. But here, as we got this spring here, spring elongates through X. So only increment on the above side of the pulley required is X that comes from the block A as it move up along the incline by X. So the acceleration of block A is also A1. So let us pronounce this A1 as your A. Now let us see what happens. So tension here is also T1. If I put equation for 20 root 3 block down the incline, we can write 10 root 3. Here I have to put a G as well. 10 root 3 G minus T1. That should become equal to product of mass and acceleration. So we can write here. And in the spring, due to elongation, if the force is kx, here in this string, as it is connected to that spring, the tension should be, let me say, T3, that is also kx. As that is kx, here let's write T2. T2, we can say that it is 2 times kx because the pulleys are massless. Net force on the pulley should be 0. On the right side of this pulley, there is kx plus kx acting. So left side 2kx should be there for net force to be 0. So for 5 kilogram block, if I write the equation, so T1 minus 2kx, T1 minus 2kx is mass into acceleration, that is 5a. And for this block A, if you write, the tension in the string is T3, and you would have 10g, that is mg sine 60 down the incline. That would give us so 5 root 3 g. So we can write that T3 minus T3 means kx, kx minus 5 root 3 g is equal to product of mass and acceleration of that block, even that is kx. So now here, so as to find the acceleration, we can eliminate the things. So let me multiply the upper equations. Say if I multiply this with kx as with 2, and add it to this equation, these two would give me T1 and 2kx get cancelled upon addition, minus 10 root 3g equal to 25a. And if I add these two equations, then I would get 10 root 3g gets cancelled. T1 also gets cancelled. So 20 root 3 plus 25. 20 root 3 plus 25 into A is equal to 0. Implies acceleration is 0. Implies system remains at rest, it doesn't move. So for the answer of first question, you want T1. Shouldn't I say for this block C remains at rest? So T1 equal to 20 root 3 times G. 20 root 3 G. So G is 10. So our answer would be 200 root 3 newtons. Oh, I'm sorry. This is into sine 30 we are left with. So because tension should be 20 root 3 sine 30, that would give us 100 root 3 newton. Is the answer for this question. Now this if string between B and C is removed, that means the left part of the string, the left of 5 kilogram block is removed, then the magnitude of acceleration of block becomes what? Actually, as we know, this 5 kilogram block is at rest. How is it rest? It is at rest under the influence of the forces. What forces? The 5 kilogram block is experiencing a T1 force to the left, T1 to the left, and 2kx to the right. Now it was at rest. That means T1 bar plus let's say this is T2 2kx. Let us call it as T2, T1 bar plus T2 bar is 0. I do in the next page. So T1 bar plus T2 bar is 0. Uh, that's the net force. But now T1 bar is absent. Only T2 bar is present. Therefore, the unbalanced force would become T2 bar. But how much is T2 bar? T2 bar is T1. T2 bar is same as the magnitude of T1 because the system, 5 cage block was at rest under the influence of T1 and T2, so they are equal in magnitude, opposite in direction. We got that as 100 root 3 Newton. Uh, so 100 root 3 Newton is the force. So you want the acceleration. Acceleration is unbalanced force 100 root 3 by mass of it. So you would have 20 root 3 meter per second square. Is that acceleration of this 5 kilogram block? After removing that left side string, the left side string is just cut, you would get this acceleration. And we are not considering any changes in T2. The reason is we got a spring on the right side. Because as soon as you cut this left side string, there won't be any abrupt changes in the spring. For the spring compression's elongation, some time is elapsed. Already the spring has suffered an elongation x, so it got some elongation because there is some force. Kx is not zero force. So you see that mm, just after cutting that left side string, the right side forces do not change on the 5 kilogram block. Hence the acceleration is that. Now here to the class I am adding some assignment questions. I'm leaving those questions for your practice, whose discussion could be done in the next video. I'll just show you the questions, read out the questions. You can just note down and give a try. Here is a question. In the figure, there are two particles A and B, each of mass m. A is connected to ceiling by a light inextensible thread OA, and B is connected to A by the light inextensible thread AB. Initially, line OB is vertical, system is released from rest. Initial acceleration of A and B are given A1 and A2 respectively. You have to find the value of 5A1 by 2A2. You can keep a pause and note down the question and solve the question. Here is one more question, and from the mechanics part. A particle is initially at a distance d equals 16 meters from a fixed point O. The particle P moves with velocity v bar, which is equal to 5 PO cap and 3 I cap, where PO cap is the unit vector from P to O at any time t. Initially, PO cap is perpendicular to I cap. Find the time in seconds after which P meets point O. You can note down and give a try to this question. And here is another question. From a certain tower of unknown height, it was found that the maximum range at a projection speed of 10 meters per second was obtained at an angle of 30 degrees above the horizon as shown in the figure. What is the range of this projectile, assuming g equal to 10 meters per second square? You're also asked to give the height of this tower. You can give a try to these questions. The discussion could be done in the next class.